In this video, I'm going to show how you can graph a rational function. When you have a rational function, it is wise to find the asymptote lines. Now, you have a couple possibilities for your asymptotes. You got a vertical asymptote, you could have a horizontal asymptote, or you may just have no horizontal, or you could just have a oblique or a slanted asymptote. So first, define the vertical asymptote. To find the vertical asymptote, you're going to look at the denominator and you're going to set it equal to 0. So I'm going to have x minus 2 equals 0. Now the vertical asymptote is going to be what makes the denominator undefined or equal to 0. So if x is 2, then the denominator is equal to 0 and I can't solve it. So that's where our vertical asymptote line is going to be. So to put that in here, I'm going to click the vertical asymptote, and here I'm going to put the coordinates of the vertical asymptote, which would be 2, 0. So it crosses the x-axis at 2. Next, I have to determine, is there a horizontal asymptote? Well, because the numerator has a degree of 2 and the denominator has a degree of 1, I don't have a horizontal asymptote. Although I would have an oblique asymptotes. So to find the oblique asymptote line, I can use synthetic division here. So with synthetic division, I'm going to take my vertical asymptote, which is positive 2, and I'm going to divide that. I'm going to take the numerator, the coefficients of my numerator, so negative 2, 4, negative 1, and divide that by a positive 2. So to do that, here I have 2, and I'm going to divide that by negative 2, positive 4, and negative 1. So with the synthetic division, I bring down the first term, multiply on the diagonal, add straight down, multiply on the diagonal, add straight down. And since I started with a degree of 2, I have one less degree left in my answer. So this would be negative 2x plus 0 with a remainder of negative 1. But for this, I don't worry about the remainder. I just want to focus in on the linear part. So I have a linear equation of negative 2x. So I'm going to go back to my coordinate plane, and I'm going to plot the slant asymptote. So my first point crosses the y-axis at 0, 0. So I'm going to plot that down first. And then it's got a negative slope. So that means it goes down to the right one. So this is going to be a 1, negative 2. Draw the asymptote line in there. And now from here, I need to plot 2 points on each side of the vertical asymptote. So we're going to grab our calculator here. And we're going to start putting numbers in here. So if I put a 3 in for x, so I'm going to have negative 2 times 3 squared plus, and I'm going to have 4 times 3 minus 1. And that's going to give us a negative 7. And if I put 3 in the denominator, 3 minus 2 is 1. So if I divide that by 1, you get an answer of negative 7. So that means I'm going to have a point at 3, negative 7. So 3 down to negative 7 would be right here. And then if I put a 4 in for x, so I'll grab our calculator again. If I put a 4 in for x, I have negative 2 times 4 squared plus 4 times 4 minus 1. That's going to give us a negative 17. And I'm going to divide that by 4 minus 2, which is 2. And I get negative 8.5. So if I plot that one, here we're going to have 4. And then this was a negative 17 halves. So I'm going to use this one here. So negative, and then 17 halves, and plot that one. So that part is finished. Now I need to go to the other side of the vertical asymptote, so I'm going to put a 1 and a 0 in. So we grab our calculator again. So if I put a 1 in there, it'd be negative 2 times 1 squared plus 4 times 1 minus 1. That's going to give us a 1, and I'm going to divide that by 1 minus 2 is negative 1. So I divide that by negative 1, I get negative 1. So I'm going to have a point at 1, negative 1. So 1, negative 1 would be here. And then the next part, I'm going to put a 0 in. If I put a 0 in, I'm going to get negative 1 on top and a negative 2 on the bottom. So that's going to give me a positive 1/2. So if I put a 0 in, I get a positive 1/2. Plot that point. From that point, I should be able to put the lines in here for my graph and then check it. And that one is correct. So that's how you can graph a rational function.